Alrighty, today we're going to go over the 3.1 homework. So on page 169 and 170, it's number 1, then 2 through 62 even. Now in this section, you really have to understand that we're going to tie together roots and fractional exponents. So beforehand we used square roots. That was our previous. Square roots were a check mark with nothing there, and we would sometimes put a little 2 there. Alright? Square roots undid anything with any perfect square. They cancel each other out. But now we're going to change that number. We're going to change the index. So if you hear me say index, I'm talking about that little number right here. And then to do that, you're going to need to find perfect of roots of whatever power that you're using. Now sometimes it might be easier to deal with something with a fraction exponent, and sometimes it might be easier to deal with something with a root. So we're going to do both of those today. So number 1 says, in the expression, the 4th root of 10,000, the number 4 is called the index. So that's what's going to identify our type of root. So it's the 4th root. So its index is 4. All right. Number 2 says, explain how the sign of A determines the number of real 4th roots versus the number of 5th roots. Okay. When you have 4th roots, that means your index is even index. All right. You have 2 solutions if A is positive or greater than 0. Remember, that's when we need the plus or minus. You have 1 solution if A is equal to 0, and you have 0 solutions, 0 real solutions, if A is less than 0. Because remember, that's when I shows up. Now, with 5th roots, it's really easy. Always 1 real solution. And that's it. Alright, number 4, they say 2 to the 3 halves. We're going to use this formula right here, A to the m over n. And I'm going to rewrite it as a radical. So I have a fraction exponent. That's a fraction exponent. I'm going to rewrite it with a radical. So I say A is 2, because that's 2. M is 3. N is 2. And I just plug it in right here. So I have the second root, or the square root, of 2, because A is 2, all to the 3rd power. Remember, the book never writes that little 2. So they're just going to erase it. So your final answer is going to be the square root of 2, all to the 3rd power. And if you look at that matching, that is A. And that's it. Alright, 6, we're using that same formula. A to the m over n equals the nth root of A, all to the m power. A is 2, m is 1, n is 2. Plug it in right here. So I have the square root of 2, all to the 1st power. Remember, the book's not going to write that 2, and also the book's going to simplify that because it's to the 1st power. It just simplifies to the square root of 2, which is B. And that's your final answer. Alright, in 8, we're going to use the same exact formula, except I have this side, so I'm going to make the fraction exponent show up. So I still got to find A, which is 8, because that's right there. M isn't, I don't see an M, so if you don't see an M, it's automatically 1. And N is 5. So now I make this side show up, so I just say 8 to the 1/5. And we're done. And that's it. Alright, 10, very similar. It's a little bit harder just because of the parentheses and multiple things going on. And we're going to change the formula just a little bit. So the formula we're going to use is we're going to say the nth root of A to the nth. So we're just changing it a little bit. They're both mean the same thing algebraically. So I'm still going to find, I have the radical side, so I'm going to make the fractional exponent side show up. So I say A is the entire part. A is the entire part, y plus 2. M is 2. N is 5. So I just finish this up as y plus 2 all to the 2/5. And that's my final answer. That's it. Alright, we're back to using that previous formula. So I have a to the m over n equals the nth root of a all to the m. Well, I have this side, so I'm going to make this side show up. So a is 7, m is 1, n is 3. So I'm going to make this the cube root of 7 all to the first power. And the book's going to want you to simplify that, so your final answer should just be the cube root of 7. And that's it. Alright, we're going to use that same formula we've been using. So a is x, m is 7, n is 6. Now remember, since I have a fraction exponent right there, I'm going to make the radical show up. So we'll write this as the 6th root of x all to the 7th power. I would take that, or you could have wrote it as the 6th root of x to the 7th power. These are both kind of the same thing, so I'll take either one. That's it. Alright, 16, you're saying find the nth roots, so you're going to be using this formula right here. They're not giving you an m, so m is just 1, so you don't even need to write it. So I just write this as the cube root of negative 27. They're not telling you to change it. They're telling you to actually simplify it or find the root. So what you have to do is you have to write negative 27 as a perfect cube. Why is I'm looking at cubes is because the index is 3. I want those indexes and the little exponent on the inside to match. So I start with cubes. So I say 1 cubed is 1. Not going to help me. I'm looking for negative 27. 2 cubed is 8. Not going to help me. But 3 cubed is 27. And since they're both odd, since it's an odd exponent, negative 3 cubed is negative 27. So I'm going to rewrite negative 27 as the cube root of negative 3 cubed. Since this 3 and this 3 match, they cancel. Your final answer is just negative 3. Remember, you must show your work. Or how do I know you didn't just use a calculator to get the answer? Alright. Alright, in 18 they're giving you n. They're giving you a, so you're just going to plug it into that formula. So I have the cube root of 343. I need 343 needs to be a perfect cube. So I start with my cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. 5 cubed is 125, 6 cubed is 216, 7 cubed is 343. So wherever I see 343, I'm going to write 7 cubed. So I said the cube root of 7 cubed. Now my little 3's match, so they cancel. My final answer is just 7. 20, exactly. Alright, so I'm going to make this the 5th root of negative 32. Now, because of that index, I'm not looking for cubes anymore. I'm listing perfect 5th powers. So I start with 1 to the 5th. It's 1, not going to help me. 2 to the 5th. That's 32, which means if I make it negative 2 to the 5th, I get negative 32, because that's an odd exponent. So I rewrite this as the 5th root of negative 2 to the 5th power. The 5's are matched, so they cancel, so your final answer is just negative 2. So your whole goal in all of these is to make the number on the inside a power with the little number on the outside. That's 20. Alright, on 22 to 32, what you have to remember is that since we are not using a calculator, we put everything in radical form. So if you don't see a radical to start, you know you eventually have to make one, because that's the only way you can do the problem without using a calculator. So 22, I have 8 to the 1/3. That is not in radical form. That's fraction exponent form. So I use this formula, a to the m over n. The nth root of a to the m. So I say a is 8, m is 1, n is 3. So this becomes the cube root of 8, and since it's to the first power, I just leave it that way. And I rewrite 8, since 2 cubed is 8, I rewrite 8 as the cube root of 2 cubed. The cube root and the cube undo each other, so my final answer is just 2. That's it. We have the cube root of negative 125. Now that's already in radical form, so I'm just going to make negative 125 a perfect cube. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, which means negative 5 cubed is negative 125. So I write this as a negative cube root of negative 5 to the third power. The 3's cancel. You're left with negative 5. That's it. Alright, 26, we have negative 243 to the 1/5. Because it's a fractional exponent, I'm going to use this formula to change it into a radical. So A is negative 243, M is 1, N is 5. I'm going to plug in, I get the 5th root of negative 243, and since M is 1, it's just to the first power, and we'll leave it that way. Now, I'm going to write stuff to the 5th power because the index right here is 5. So I say 1 to the 5th is 1, 2 to the 5th is 32, 3 to the 5th is 243, which makes negative 3 to the 5th negative 243. So I rewrite this as the 5th root of negative 3 to the 5th. The 5's cancel. My final answer is just negative 3. That's it. (28), I have the cube root of negative 64 to the 4th power. It's already in radical form, so I'm going to just break this down. So I have the cube root of negative 64. I'm going to look for perfect cubes because I have an index of 3. So I have 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. That means negative 4 cubed is negative 64. So I have the cube root of negative 4 cubed. My 3's cancel. My final answer is negative 4. Okay, that's it for 28. 30. I have 25 to the 3/2. Fraction exponent. I can't do that in my head, so I must use this formula. A to the m over n equals the nth root of a all to the nth power. I rewrite this since a is 25, m is 3, n is 2. I write this as the square root of 25 all to the 3rd power. Now don't forget that it's to the 3rd power. A lot of guys, they forget that this exponent's still there. So I do the square root of 25, which if you didn't know, I make that little 2, 5 squared. They cancel. So I end up with 5 to the 3rd power. Because I didn't forget my exponent, so 5 to the 3rd is 125. That's my final answer. Alright, 32. I have 1 over 81 to the negative 3/4. Now, first of all, we can't do anything with negative exponents, so we don't want negative exponents. So no negative exponents. But we have a way to get rid of negative exponents. If you remember, we have these formulas that says if you have a negative exponent, if you move everything to the opposite side of the fraction, it will change that exponent sign. So if I take all this stuff and I kick it upstairs, it makes that negative 3/4 positive 3/4. So that's the first thing I'm going to do. So this is 81 to the 81 to the 3/4. Now I get to use my formula, where this is a, this is m, and this is n. So I get the 4th root of 81 all to the 3rd power. A lot of people forget that m's there. That m is there. It's 3rd power. If I go through 4th powers, 1 to the 4th is 1, not going to help me. 2 to the 4th is 16, not going to help me. 3 to the 4th is 81, that's going to help me. So I take 3 to the 4th and I replace it with 81, so I get the 4th root of 3 to the 4th all to the 3rd power. The little 4's cancel. You're left with 3 cubed, which is 27. That's your final answer. Alright, on 34 to 44, you're going to use the calculator. So you're going to just plug them into the calculator like we did in class, and then give me the decimal answer. Alright, 34, you have the fifth root of 32,768. To plug this into the calculator, you're going to press 5. Then you're going to hit the second button on your calculator. Then you're going to hit the caret button, because above the caret is something on the screen that will show up x radical. Then you type in 32,768. You hit the equal sign, you're going to get 8. That's it. Alright, we have the ninth root of negative 230. So in 36, I'm going to press 9 on my calculator. I'm going to hit second. Then I'm going to hit the caret button, because above that I want the x radical. Then I'm going to hit the negative button. Then I'm going to hit 230. I'm going to hit equal sign. And I end up with negative 1.83. That's it. 38, we have 25 to the negative 1/3. So I'm just going to plug in my calculator and hit 25. And hit the caret button, negative 1. I'm going to hit the ABC button, ABC, 3, hit equals. I end up with 0.34. That's it. Alright, in 40, I'm going to type left parenthesis 4, second, hit the caret button, because remember we want that x radical button, 187. I'm going to close the parentheses. I'm going to hit the caret button again. And then I'm going to hit 3. Then I hit equals. I plug that in. I end up with 50.57. That's it. Alright, 42. We have the fifth root of negative 8 all to the 8th power. So in my calculator, I'm going to type in left parenthesis 5. Hit the second button. Then I'm going to hit my caret button, because I want that x radical button. Negative 8. Close the parentheses. Caret again. Then to the 8th power. And finally hit my equal sign. And I am going to get 27.86. Alright, in 44, we have 1,974 to the 2/7. So you're just going to type in 1974, hit the caret button, 2, then you get the ABC button, 7, hit the equals button, you're going to get 8.74. That's it. 46, you're going to plug them all in. You're going to find out B is the greatest. Alright, 48. Remember, we're solving. Now that we're solving, we're going to use PEMDAS backwards. Remember, we start from the bottom and work our way up to solve. And addition and subtraction undo each other. Multiplication and division undo each other. And to get rid of an exponent, you use the corresponding radical. So to get rid of an exponent with a 3, I have to use a cube root. And so I have x equals the cube root of 27. Well, what I have to understand is I have to find 27 as a perfect cube. Well, 3 cubed is 27. So I write x is equal to the cube root of 3 cubed. The little 3's cancel, so x is equal to 3. The book said the cube root of 27 equals 9, which is not true. And that's their mistake. Okay? That's it for 48. Alright, in 50, remember we're going to once again use PEMDAS backwards. So remember, when we solve, we go backwards. And addition and subtraction undo each other. Multiplication and division undo each other. And to get rid of that exponent, you have to use the right root. You have to use the correct root. So there is no subtraction, no addition, no division, no multiplication. I immediately use a root, but remember, it's got to be the cube root. So these 3's cancel, so I'm going to just x. Now I need to make 125 as a perfect cube. Well, the cube root of 125 is 5 cubes, so those cancel. You're left with x is equal to 5. And that's it. Alrighty, I'm going to use my PEMDAS backwards. So the first thing to do is subtract 36 from both sides. I get x to the 6th equals 64. Now I take my root. I have the 6th root of both sides. Remember, these 6's have to match. That's why I have a 6 here, so the x goes away. And I have to write 64 as something to the 6th power. So I have to say the 6th root of 2 to the 6th, because if I write out my 6 powers, 1 to the 6 is 1, 2 to the 6 is 64. So I write that out, they cancel. But remember, since 6 is even, I have to have x equals plus or minus 2. Right, and that's your final answer. 54 is x to the 5th minus 48. Equals negative 48. So when I do PEMDAS backwards, the only thing I have to do is the 5th root of both sides. Those cancel, so I have x is equal to the 5th root of negative 48. Today, you're allowed to use your calculator. We'll talk about how to simplify things like this in the future. But right now, use your calculator. Plug it in. You get x is equal to negative 2.17. That's it. Alright, x cubed plus 40. I subtract 40 from both sides. I get x cubed equals negative 15. Now I take the cube root of both sides. I get x is equal to. Now, once again, this cannot be broken down because there are no cubes that give me 15. So I use my calculator. I get x is equal to negative 2.47. And that's my final answer. Alright, x to the 6 minus 34 equals 181. So before I can get rid of that little 6, I have to add 34 to both sides. I get x to the 6 is equal to 215. So then I'm going to take the 6th root, both sides. I'm going to use my calculator, because this is not a perfect one and we haven't talked about how to break that down yet. So I end up with x is equal to 2.45. That's it. 60 and 62 will be graded for accuracy in class. There are 2 mistakes somewhere throughout this video, so don't forget that. And have a great day.